Hi, this video is about the language of physics units and metric prefixes. Now, in physics, we want to make sense of the world. And in order to make sense of the world, we need to be able to make measurements. We need to measure things. And one essential piece of any measurement is the unit of measurement, or a known quantity. That's what a unit is, a known quantity. So, for example, the Earth is 8,000 miles in diameter. We know what a mile is, it's a known quantity, and that's our unit. A penguin can swim at speeds up to 22 miles per hour. Again, this is a speed unit that we know, we're familiar with. A can of Diet Pepsi contains 0 calories. Again, a unit that we're familiar with. Now, in physics, the units that we use are not necessarily ones that we're familiar with in everyday language. And that's because physics uses the International System of Units, which is sometimes abbreviated SI. It's SI and not IS because SI is the abbreviation for the French name. It's like, I can't even pronounce it, but that's why it's SI. It's flipped around in French. So System International, or SI units, also called the metric system. So you've probably heard about the metric system and you're familiar with some pieces of it. I mean, in America, we only use the metric system a little bit, but we use the imperial system for most things, like miles, for example. But in the metric system, there are no miles. Instead, we use meters to measure distance. Instead of using pounds to measure how much something weighs or the force of something, we use newtons. And of course, we also use kilograms in the metric system to measure mass. For speed, we're used to measuring speed in miles per hour, but that becomes meters per second in the metric system. And also in the metric system, we have a kind of a shorthand language, a kind of an abbreviation system for keeping track of how big or small certain units are. So instead of having like the imperial system, the system we're used to, I think of like baking in the kitchen. Instead of having like, you got the gallon and the quart and the pint, and then you got the tablespoon and the teaspoon. Instead of keeping track of all of those different units of measurement, in the metric system, there's just one unit, and then there's a bunch of prefixes that you can put in front of that unit. So, for example, you might have a meter as your base unit and you're measuring distance. Well, if you wanted to say how much distance you had, for example, or you might have heard of a kilometer, right? A kilometer, right? A kilometer represents 10 to the 3 meters. Kilo is 10 to the 3, so you put that in front of meter. Kilometer is 10 to the 3, or 1,000 meters. And you can see this whole chart here kind of gives you some of the most common prefixes that we use in physics. Now, there are more than this. I didn't include all of them. I kind of just included the ones that we use in this physics class. But there's plenty more out there that are not as important for this purpose. But what is interesting, and maybe you'll become familiar with this as we go on, is that it kind of goes by threes right here, and that represents thousand, million, and billion. So, for example, for computer files, I think of them in megabytes and gigabytes. Right, a gigabyte is 1 billion bytes. A megabyte is 1,000. Or sorry, I said that wrong. A gigabyte is 1 billion, and a megabyte is 1 million, and that's 10 to the 6 and 10 to the 9. And then when we get smaller down here, the one that I wanted to point out is this one right here. A microgram or micrometer is represented with this letter here. This is the Greek letter M. It's called a mu, and so that's why it looks a little different. It's kind of like a U with an extra tail in the front, and so that's how I write it. And this is 1 millionth, and then nano is 1 billionth. So, for example, 1,000 meters is 1 kilometer. Now, this chart right here is one that you might want to have a copy of somewhere to keep track of, because we're going to refer back to this and we're going to use this information a lot. And it's a lot to memorize. And so if you could just have a place that's easy to refer to in notes or something like that, then it's probably going to be beneficial when you're doing physics to have this kind of information close at hand. So let's look at some examples. So let's start with these examples here. So as I was saying before, a metric prefix is kind of like a code word. It's like a language, right? And it's a code word that represents a multiple of a unit. So for example, let's start over here. 4 kilograms. Kilo represents 1,000. And so when you rewrite this, you can translate this, think in language terms. You're translating from a prefix down to the base unit. You can translate kilo as 1,000. And specifically, it's a math operation, a multiplication operation here. So 4 kilograms is 4 times 1,000 grams. So kilo represents times 1,000. So that would be 4,000 grams. 25 centimeters. If you replace the centi with what it actually represents in terms of a numerical value, it's times 1 over 100, or 100th. So 25 times 1 over 100 would be 25 hundredths of a meter, or in decimal form, which is the form we often use, 0.25 meters. Put it in a calculator if you can't do it. Often you just are moving the decimal place back and forth. 723 milliseconds. Milli, if you look at the chart, is times 10 to the negative 3, which is times 1 over 1,000. So that would become 723 thousandths of a second, which would be in decimals 0.723 seconds. And then finally over here, micrograms, just to get used to that one. Micro, looking at the chart, is 10 to the negative 6. And so 5.2 times 10 to the negative 6, that's 1 over 1 million. 5.2 millionths of a gram in decimal form, it's that. I'm not going to try to read that. But that gives you the idea of how you can take a metric prefix like micro, milli, and you can replace it and swap it out with its numerical value, and it still is a true statement. You're still saying, you're not changing anything about the measurement, you're just re-representing how you're communicating that measurement. All right, so let's look at a few final examples here. I've got 3 that I wanted to just show you briefly of converting between units. So let's look at this one here. We have 200,000 milligrams. How many grams would that be? This might be an example question that you have to do for an assignment. So again, using the same idea, we take the milligrams, the M, we know that the little lowercase m represents milli. And so that lowercase m right there, I've highlighted it because I know that's a prefix that represents 1 over 1,000. And so I'm going to do 200,000 times 1 over 1,000 and get 200 grams. For 0.034 kilometers, how many meters is that? Okay, I see the K, and I know that that's a prefix that has a value, so I kind of highlight it here again. I'm going to change that K into what it represents numerically. So kilometer is the same thing as times 10 to the 3, looking at my chart. So 0.034 times 10 to the 3 meters. Now, I can put that in my calculator, or I can know that 10 to the 3 is just times 1,000. I can move the decimal place over 3 times as well for 10 to the 3, so 1, 2, 3. So it'd be 34 meters. All right, then finally over here, this is where it gets a little bit tricky because this is going to take us 2 steps here, because we have 6,270 centimeters, and I want to know how many kilometers that is. Now, when we're going from one metric prefix to another metric prefix, centi to kilo, we need to make a pit stop at the base unit. So we need to first take the centimeters and turn it into meters, and then we can go from meters and then go to kilometers after that. So our goal will be to turn this first into meters and then into kilometers. So let's do that. 6,270 centimeters, C, is 10 to the negative 2. So put that in a calculator or just move the decimal place over backwards 2. So that's going to be 62.7 meters. Now we want our answer to be in kilometers though. And so we're going to need to do a little bit of backwards work here. And I left some space for this purpose. So kilometers, I'm going to highlight the K again for the kilometers. I know that K represents times 1,000. I'm looking at my chart again. K is times 1,000 meters. So I would like to take this measurement of 62.7 meters. I'm going to write it like this. It's going to seem a little weird, but I'm going to spread it out a little bit like this. 62.7, I'm going to write meters over here. And so I want to have this times 1,000 meters part in here, because I know I can turn times 1,000 into kilometers. So that times 1,000, I need it to be right here. All right, so that's going to be times 1,000. But wait a second, I can't just take a measurement, 62.7, I can't just multiply by 1,000, because that'll change the measurement. So in order to make sure I'm not actually changing the amount of meters I have here, I need to kind of like undo this times 1,000. And so at the same time that I put in the times 1,000, I'm going to also put in divided by 1,000. Because if you multiply something by 1,000 and divide it by 1,000, you haven't actually changed anything, right? Now, that might seem a little weird to have all that in there, but let me show you why this works. So 62.7 divided by 1,000 is, I'm going to move it over 3 places, so 1, 2, 3, so that's going to be 0.0627. So if you look now, I have this number here that I've done 62.7 divided by 1,000. Now I have 0.0627 times 1,000. Well, wait, I'm going to keep that times 1,000 there and turn it into a kilometer. So that's going to give me my answer. So my answer is 0.0627 kilometers. And I did that through this method here. This might be a little confusing at first, but we'll hopefully get some practice in, and it'll make a little bit more sense. So that's all I have for you in this video. Remember, how you do anything is how you do everything.